So we're talking about simplifying radicals. You guys all know what a square root is. If I ask you what's the square root of 64, you would tell me 8, right? But there are some numbers that don't have a perfect square, right? Like 65. There's not just one number that would multiply times itself to give us 65, right? So that's what we're going to be talking about today. If you put this square root in your calculator, it's going to give you a decimal, right? So there's not a number times itself that goes into 12, exactly. But we don't want decimals. So what we do is try and pull out what we can. And then if there's anything left over, we leave it inside the square root. So what that would look like is we try and think of numbers that do multiply to give us 12. So what can you think of that multiplies to give you 12?
For number 1, I put the square root of 9 times the square root of 16. So pretty much 3 times 4.
3 times 4 is what you were thinking of? Okay, so 3 times 4, or 6 times 2, we can do it that way as well, are numbers that multiply to give us 12. All right. 3. The only thing that multiplies to give us 3 is 3 and 1, right? So that's not going to help us out any. But what about 4? Is there anything that multiplies by itself to give 2 and 2, right? So if you can get something like this, that means we can take it out of the square root. If you can end up with a pair of numbers. Like this broke into 2's, so I can take it out. Yes, if the smaller number has a square root. So I'm going to take out the 2, but the 3 did not have anything that it broke into, no square root. So we have to leave it underneath the square root. So you can take out anything that has a pair, but if it doesn't, you got to leave it. All right? Okay. What about number 2? What's something that would multiply to give us 24? Okay. All right, so the only thing that multiplies to give us 2 is 2 and 1, and that's not helpful, right? What about 12? What multiplies to give us 12?
4 and 4.
6 times 2.
2.
Okay. Well, look, now we have 2 2's. All right, you have a pair of 2's. And the only thing that 6 is going to break into is 3 and 2. And are either of those going to have a pair? No. So we're just going to stop right there with the 6. So I can pull out the 2's, but I have to leave the 6 under the square root. And you guys probably thought of multiple factors besides 2 and 12 that would give you 24, right? So I want to show you that you'll still get the same answer either way. So what's something else that multiplies to give me 24? What? Okay. You said 8 and 3. All right. What multiplies to give me 8? 4 and 2. And what multiplies to give me 4? 2 and 2. All right. So there's our pair of 2's that we can still pull out. And I have a 2 and a 3 left over. Well, I wouldn't write that as 2 and then a 2, 3 left under there, right? We wouldn't just make a list. If they're left over, you can multiply them back together to see what you would have. And we would still end up with 6, right? If you did, Addison, was it you that said 6 and 4? Okay, so 4 would break into 2 and 2, and we could pull out that pair, and then you'd still have the 6 left over. So it doesn't matter what you choose. As long as you break it down correctly, you'll end up with what everybody else got, no matter what factors you choose. Does that make sense? Okay. All right, number 3. So what multiplies to give us 48? 6 and 8. Okay, so I have 6 and 8. What multiplies to give us 8? Okay. All right. And is 6 going to break into anything that gives us a pair? Is 2 going to break into anything that gives us a pair? What about 4? 2 and 2. So there's my pair. I can pull that out. and I have a 2 and a 6 left over, right? But we wouldn't put a list of numbers under there, so we're going to multiply those two back together. So 6 times 2 would give us 12. Now, if I did break down the 6, what would that multiply to give me? And then we have another pair. Okay? So, if I have another pair, I would pull out that 2 as well. And then I have the 3 left over. But again, we don't want to make a list of numbers out in front. So if you pull 2 numbers out, you multiply them together. So that would give us 4 square root of 3. Okay? Okay, what about 72? What multiplies to give us 72? 9 and 8, okay. What can we break 9 down into? Good. So there's a pair right there, right? And what can we break 8 down into? Okay. And then I can break down 4 even further into, okay. So I have a pair of 2s and a pair of 3s. That means I can pull out a 2 and a 3. So if I pull out a 2 and a 3, we have to multiply them together. And what's left over that didn't have a pair? The 2. So it stays under the square root. And what is 2 times 3? 6. Okay. What multiplies to give us 108? Okay. Alright, so 2 won't break down except into 1 and 2, right? So that's not helpful for us right now. But what does 54 break into? Okay. What does 27 break into? Huh? 9 and 3. And what does 9 break into? 3 and 3. Okay, so I have a pair of 3s here and a pair of 2s over here, right? Okay, so if I pull out the 2 and the 3, remember we multiply them together, and what's left over without a pair? The 3, so it's going to stay under the square root, so I end up with 6 square root of 3. It gives you a decimal? Yeah, that's why we can't use the calculator.
When you put 6 root 3, like the first one, when you did 2 root 3, 2 root 3.
Say that again?
They equal the same thing.
Now, maybe you realized early on that also you could have broken 108 down into 12 and 9, and then you broke down 12 and you broke down 9, but you're still going to end up with the same numbers. Okay? So, again, it doesn't matter what factors you choose or what anybody else chooses, it'll all end up the same. All right, number 6. What can I break 32 into? Okay. All right. And what can I break 8 into? Okay. And you might already realize you have a pair of 4s, so you could pull out the 4. But if you didn't notice that, then you would break this down into 2 and this down into 2, right? Then you'd have 2 2s to pull out instead of 1 4. This is going to give you the same thing when you multiply the 2s together. So as soon as you notice a pair, I would go ahead and pull it out. That way you don't have to keep going. So I get to pull out a 4, and what's left over? A 2. And there was already a 3 out in front, right? So I have a 3 that was already there, a 4 that I pulled out, and a 2 left over. So I'm going to end up with 12 square root of 2. The better you know your multiplication facts, the better you can choose things like 4 and 9 and 16, things like that that actually do have square roots, and it'll make the process faster. Okay, number 7. What multiplies to give us 45? What'd you say? Okay. All right, 5, not going to break down into anything, but 9 would give us 3 and 3, and there's a pair. So we can pull out the 3. And there was also already a 5 out there. And what do we have left over? The 5. 5 did not have a pair. So we have the 3 times 5 on the outside. It's going to give us 15 square root of 5. Say that again. All right, number 8. So we're breaking down 12. What will 12 break into? 4 and 3. Good one to choose because 4 has a pair, right? 4 will break into 2 and 2. So there was already a negative 6 in front. We're pulling out a 2, and then there's this 3 left over. So I end up with negative 12 square root of 3. Okay, on number 9, what do we know multiplies to give us 200? What'd you say? 20 and 10. Okay, good option. Is there anything you can think of that's going to have a square root? 2 and 100. Right, because then we can break 100 down into, there we go, and we have a pair right away. You would still get this if you did the 10 and 20, but you'd have to make a lot more branches before you got that far. 25, and it would be 25 and 8. This is 200.
No, I did 100.
Oh, and you broke this down into 25. Okay, then you end up with 5 and 5 and 2 and 2. Multiply them together, you get 10. So I have the 10 that I pulled out. There was also already a negative 4, and then we have the 2 left over. So we have negative 40 square root of 2. All right, last one, number 10. What would that break into? What'd you say? Okay. And then 4 will break into, right. So there's my pair. So I end up with 2 square root of 11, and there was also already a 3 in front, right? So 3 times 2 will give us 6 square root of 11.